Hello, are you here?
Yes. Yes.
Okay, yeah, that's good. All right, let's just come back with our class today, and we first of all talking about the some kinds of basic about the discrete probability distribution. So we have the two different one. We will talk about the discrete random variable in this section, and the next class will be about the continuous random variable. So first of all, we want to talk about the what exactly it would be. You guys see my screen share? Yeah, that's good. Thank you. All right. So first of all, we want to talk about the random variable. So random variable, according to the definition, this will be a numerical description of the outcome of an experience. So what exactly this could be? What exactly this could be? Okay. Uh, a random variable, first of all, we have to talk about an experiment. For example, when you toss a coin, okay, or when you roll the die, okay. Anyone know about what it toss a coin? Toss a coin, okay. This means toss a coin. No, that's not this one. It's not toss a coin in the Witchers. If anyone like watch for this kind of Netflix. But when we talk about toss the coins, that means we flip it. Okay, we flip it in the air, and then when we drop it, we can see the result. The result can come out for two of them. First of all, what is this? Second of all, what this? What we call mặt sấp và mặt ngửa, đúng không? So basically they're the same with here. So when we toss the coins, we have the head and the tail. The head means the upper surface of the coin, and the tail means the lower surface of the coin. Okay. So basically, with all the things like that, when we toss the coin, the outcome would be just one, like head, or the outcome would be the tail. And what will be the probability? The tail. Anyone can tell me? How many percent that I can get the head? How many percent that I can get the tail? Anyone?
50.
Yeah, please raise your hand. Okay, Nhi, and you say?
50.
50%, right?
Yes.
And 50%. Because that actually, this has been proven by the scientists. So they say like with the two outcome of head and tail when tossing the coin, we had the equally likely possibilities of the outcome. That would be 50-50. So like half of all the probability will be for the head result, and half of them will be for the tail. Okay, and same thing with rolling the die. You know anyone about roll the die?
Yes.
Okay. If you type in like roll the die game, and they even have the online game for this, and wait for this, and the only thing that should be like all the time you click on, and you see like how the die mình cục xúc sắc, how it will roll and the result will come out, right? So how many outcome of die with 6 face that can be we have? What will be the probabilities associated with its outcome? So the outcome can be. Thank you, Uyên Nhi. I give you a kind of half of the extra credit for you. Anyone else for the outcome of the roll the dice? How many results we can have? Rồi Yến Nhi.
16.66%.
Yeah, but I'm asked about the outcome first. Let's talk about outcome first, okay? So what will be the outcome we can have for
Like
rolling a die?
a number.
Yeah, the number, but like what will be the result? So over here I have 5 here, right? And this one will be 6. So what could be all the possible outcome we can have? Can you answer it?
Yeah, from 1 to 6.
Yeah, that's right. So sometimes we can roll it like 1, right? Sometimes it'll be 2, sometimes it's 3, 4, 5, and 6. Because this could be regular die, and normally they generate for one of among 6 of the results. So this will be 1, right? Another one I have 3. Another one I have a one more time. 4, something like that. Okay, so this will be the way. So we can have the outcome from 1 into 6, and what will be, I'm sorry. So what will be the probabilities of each of them?
16.66.
Okay, why you think about that? Why you got it like 16.66? How you calculate it?
I will take 100 divided by 6.
Okay, 100% for all of them, right? So because they're just 6 outcome, so in total it should be 100. But however, so 6 of them have equal probabilities, so we divide for 6. Okay, and I put it in a percentage for you to understand. Okay, and I just go down 16.67 or 16.66. It's okay. All right, and some of them, of course, that should be 100%. Thank you a lot, like yay. Okay. Yeah, like for this one, well, like half of the extra credit for you. So you can see that will be the result, and this will be what we call the random variable. The random variable will be the numerical description of the outcome. The outcome can be this tail and the head, and the result, the probability, actually, that will be mean probability, will be a numerical result. So that's what we say about the random variable. And we have 2 kinds of random variable, sorry. The first of all would be, we talk about the discrete random variable. And the second one will be the continuous random variable. So for random variable, okay. So for random variable, all right, we have 2 different types of them. First of all, that's the discrete variable. And another one, I would say the continuous variable. Okay. Got it? Yeah. So what's the difference? According to the book, they say like about the discrete variable. Sorry, we'll just close this one. About when they talk about the discrete variable, they have they say like that may assume either a finite number of values or infinite sequence of values that can be come out for the discrete variable. So what exactly that mean? I mean, like even for me, when I read for this kind of description on the book, I totally don't understand what exactly they are, to be honest. But that's very simple when I give you exercise. Okay, the example, sorry, the example. So the example about what I already say about like, for example, I have a 5, I don't know, 5 TVs in the stock. Okay, 5 TV in stock. That means in my store I have a 5 TV. That's I already said in my inventory of my warehouse. Okay, and then I sell out the TV. So the outcome and the probability. For example, first, the outcome of selling, when I ask about the number, of TVs could be sold, what will be the outcome possible, or the possible outcome of this one? What will be the possible outcome of the number of TV? Anyone? Anyone? If I have 5 TV in the stock and I sell out the TV, so for each day, maybe I can sell like 1 TV, right, 2 TV, something like that. So what will be the possible outcome of the number of TVs that could be sold each day? What will be the outcome? Anyone? Okay. Nhi, Ngô Hồng Yến, Yến đi.
Maybe 20% for it today.
I'm not talking about probability, but I'm just talking about the outcome possible. What could be the number of TV could be sold if I have 5 TV in my store?
1 for each day.
No, I mean like in that day, maybe I can sell more than 1 TV, right?
Yeah.
Yeah. I mean like just in one day, how many TV that I could be sold? That could be sold.
5.
Could be 5. Yeah, that's right. Could be 5. But how about that? How about the other? Can I sell it like 3?
Maybe.
Can I sell just 3?
Yeah, it's good.
That's possible. Yeah. And how about the other?
Maybe 1 or 2 or 4.
1 or 2, right? Because I have 5 TV in my store. I can sell it like just 1 TV in the day because today not a very good day and just 1 customer come into the store and they buy it. Just 1 TV. Or maybe today very good day and all the customer come in that they enjoy about my TV and they interest about my TV because that look very cool. A new brand and best fans that is TV with the smart TV and with the internet connection, something like that. And they want to buy it all. So I can sell it like 5. And maybe I can sell like 4. And how about the other? Or maybe on those days,
Maybe 0.
0. Yeah, that's right. So that's not very my day. So I cannot sell anything. So can I sell it up to 6?
No, because
because
5 on the inventory.
Okay, I just have a 5 in the inventory, right? All right, so I cannot sell it like 6. Can I sell it like 4.5 TV?
No, because the TV is not can divide it into a half.
Okay, we cannot divide it into the half, so that's very easy. Okay, got it. So this is a point. This will be what I say about discrete variable. Discrete variable mean all the outcome. They have to be a finite number of values. So with here, I have a 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5 from 0 to 5. So this will be 6 outcome. That will be all the finite number of value, right? Finite number of values, and here does I have a 6 outcome. But however, the result will be sometimes different a little bit. For example, now I'm not talking about that. I'm giving you an example about. Thank you, Nhi. I give you one extract right here. Okay. The example about asking about the number of students come to discuss with thầy Cường about the homework, okay? About the homework on maybe Tuesday today. So anyone can guess about the outcome for the number of the student can come to my office on via UK and ask about the outcome that could be possible. How many students could be possible? Anyone? Hồi nãy là Yến quên thầy xin lỗi Yến đúng không?
Yeah, Yến.
Yeah, sorry. Yeah, that'd be Yến. Okay, sorry. Anyone? That should be Nhi or Uyên Nhi want to answer this question? Nhi or Uyên Nhi? Okay, Uyên Nhi, can you answer this question? Student? No? Uyên Nhi? Okay, Nhi, Yến Nhi?
Dạ, thầy.
Okay. Can you guess about the number of the student can come into discuss in my office? This could be?
It could be 10 or 20.
Okay, 10 or 20. Okay, fine. 10, okay, or maybe 20. Something like that. Any other question? No, any other possible outcome? Can it could be like 0?
Yes.
Can it could be like 1?
Yes.
Yeah. Can it could be like 2?
Yes.
Yes. My question would be only very simple. So, oh no, sorry. So is there any difference between the first example about the number of TV I can sell in the store and this one?
Yes.
What that?
The example of the student doesn't have the limitation.
The limitation, yeah. So in those days, the number of students come to discuss with me, maybe just 1 or maybe 0, because they're all the day. Nobody want to care about the homework, and nobody want to come to my office to talk about that one, right? So the 0 student want to come. But however, sometimes they will be very hot topic, and a lot of students come in, and maybe it's just not 1, maybe it's just not 2, maybe 30 or maybe 40. And the same thing happen if it's just not like the number of the student, but like the number of customer. The same thing. The customer come to a store per day. Okay. So they also have an upper limit. So this is what the people call the infinite. Okay. Value. Okay. That would be the point. You got it? The infinite sequence of value, and here we don't have the upper limit. They will be infinite. They can continue until very long and whatever you want. So that should be what will be called the discrete random variable. Nói ngắn gọn là các discrete random variable là những cái giá trị mà chọn nhận ra những giá trị số. Hắn rất là tròn. Hắn tròn ví dụ như 0, 1, 2, 3, 4, 5. Hắn không thể nhận con số ví dụ 5.5 được. Vì nó là một con số rất là lẻ. Nguyên nhân vì rằng nếu như mà có 5.5 nữa thì sẽ có thêm 5.5.1, 5.51, 5.551, 1 gì đó. Thì như vậy chỉ riêng cái khoảng cách giữa số 5 với số 6 chẳng hạn là có một loạt các số như vậy. Thì nó gọi là các infinite value. Nhưng mà các infinite value không phải là một sequence of the value, cho nên cái này có phương án 1 là những cái giá trị này, các giá trị chẵn là giá trị tròn số nhưng mà có giới hạn số lượng outcome. Phương án 2 là không có giới hạn số lượng outcome, nhưng mà ngược lại nó vẫn ra những con số tròn số. Ví dụ như cuối cùng số customer coming to a store a day thì nó có thể là 0 customer, 1 customer, 2 customer, nhưng không có trường hợp là ví dụ như 2.1 customer được. Okay, let's give you the point. And the other, in the opposite side, we talk about the continuous variable. And continuous variable may assume any values in an interval or a collection of interval. You feel it's very hard. Give an example. Okay, thank you Nhi. Và thầy kêu em này. Cho nên okay, just like half of the extra credit for Yến Nhi, okay? All right, the example. This time I will talk about the ways of a student. So the outcome for a way of the student. Okay. What will be the possible? For example, I will ask about like in kilogram. Okay. In kilogram. Okay, so what do you weigh about in kilogram? And the student, they can have a different kinds of outcome. Some of students can say like, oh, I'm 65 kilogram, and another one very kind of big and fat and tall guy, that should be 80 kilogram, and another one could be like 71 kilogram. This is my question. So why different? A student have a weight like 71.5?
Yes.
Yes. Can a student even have like 71.56?
Yes.
Yes. And even if you have a very good scale, like what you do in the jewelry store, trong những tiệm kim hoàng á, có cân tiểu ly á, that will be very kind of like nano scale, and even they can put it like into very small gap like this much. and that would be that's mean. Between 71 and 72, right? For example, between 71 and 72, you can put whatever the number mean, like this, and they still be there. So that means between 71 and 72, there will be an infinite number. That will be any numerical value in an interval between like 71 and 72. There will be a lot, 1,000 of them. So basically, with the continuous variable, we have the infinite number possible of the outcome, and they can be very, very, very small. Okay. Nhưng mà những giá trị nào liên quan tới weight chẳng hạn, ví dụ như về liên quan tới hồi nãy về số người đúng không, hoặc liên quan tới số tivi bán ra thì nó sẽ là những con số chẵn thôi, không phải số chẵn, số tròn, các số tự nhiên ví dụ như là 1, 2, 3, 4, 5. Nhưng mà ngược lại đối với những con số như vậy này, những con số mà liên quan tới weight chẳng hạn, liên quan tới về height, chiều cao chẳng hạn, liên quan tới income chẳng hạn, đúng không? Thì income, ví dụ income của một người giá là ví dụ 2,1 triệu, 2,15 triệu hay 2,152 triệu, nó vẫn là được, rất bình thường. Đó, thì những cái này gọi là những cái infinite any value number, and that's the difference between the discrete random variable and the continuous random variable. Can you get it? Can you get it? Okay, that's fine. Okay. Right, so that should be the basic about the random variable, and they provide some kind of example about this one. My friend here talking about the market all the time, and right here I'm not teaching for you. Okay, for example, the discrete random variable for the finite number, that should be number of TV sold in the store. Okay, it can take whatever, like from 1 into 4, because they have just 4 the TV in the store. So they have a limit upper, the finite limit upper for the number of TV can be sold out. Okay, and for infinite number of values, so we have talked about the customer arriving in one day for the store. So the number can be 1, 0, 1, 2, 3, 4, 5, 20, 1,000, or even a million customer, whatever. So there are no upper finite limit for the variable. So in this case, we have the infinite number of values. But however, the value itself has to be very rounded, and this would be the natural number. Okay. This could be another example. The distance. So they say about family size, number of the people, right? Number of the people in the families. That will be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. But they will be have the discrete variable. But however, when you talk about the distance from a home to a store in a highway, so from our house, right, into the highway, it can be whatever in the like kilometer. It can be 1 kilometer far away from our house, but it may be like 2 kilometer, but like 1.55, 1.51 kilometer, that'd be fine. So they have a kind of like continuous variable like that way. All right, and the discrete, mainly of this topic, we will talk about the discrete probability distribution, and the probability distribution will be the random variable describe how the probability distributes over the value of the random variable. So in here, I give you a number of earthquakes from like a paper, and they provide for the number of earthquakes that can happen in the area for like in 1 month. Okay, for like in 1 year. Okay, for example, I had the data. Okay, so I had the data from like 20 years, and I already collect all the data about how many of the earthquake had been appear in each year. For example, in the first year, they don't have any like earthquake. That's a very good one. That's a very good year, and we are lucky we don't have the earthquake. That's cool. However, in the second year, in those years, we have the like 1 earthquake. In the third year, we have like 1 earthquake. Some year, like in the 7th year of the surveys, they have 2 earthquakes. All right. So the same thing happened again and again, and we collect the data for 20 years continuously. Now let's go and generate for a table like this. How we gonna do it? Anyone remember? How are we gonna do it? Anyone? Uyên Nhi? Uyên Nhi? You raising your hand? Something? Hello, Nhi. Are you here? No. If not, please just lower your hand. Okay. All right. So the outcome for me to summarize for this data and see the probability. So you can see over here, I go in and collect it. And I'm going, this is the same like pivot chart and pivot table. Remember about this friend? Okay, and I generate it for the report over here. Okay, I will just extend it for you to understand it clearly. So now I want to count for the number of the earthquakes. How many years does have a 1 earthquake? How many years have a 0 earthquakes? And how many years have a 2 earthquakes? So I count it and score it like into the round, right? And I see like there's for 3 different unit variable, unit value, including from 0 into 2 earthquake for a year. And I want to count for how many of them. There's not some I put in like just counting. So we can see how many years in total, 20 years. There 10 earthquakes have a 0. 10 years have a 0 earthquakes, and like 6 years have a 1 earthquake, and 4 years have a 2 earthquakes. And if you want to just have to see the probability, okay, probability, you can have like 10 divided for 20, but remember to just figure. Okay, so that's 50%. Okay, and the same thing now I do it with the 6 over for 20. Should be 30%. And the last one, 4 over 20, that should be 20%. So you can see over here, and of course the sum will be 100%, of course. But you can see over here, this is the same, and this will be the graph too, okay, if you want to put it in. But that could be the demonstration about how the people can summarize everything into the probabilities table. Okay, save for all the data into the table, and you see like we have 50% that there will be 0 earthquake in this year. We predict that there will be about 30% that we can have a 1 earthquake this year. We predict that we have a 20% that we're going to have a 2 earthquake for a year, and that's going to be what the people do for the discrete probability table. Okay, so we have the 2 ways to generate for the discrete probability distribution. First way, we do the same thing like this. We just do everything by counting and assign for the number. Another way, we use the spectral mathematics formula. That will be something we learn for the later in the chapter. But however, you can have the 2 ways to create a graph like this. I have a demonstrate for you the first time. Use the rule of assigning probabilities to have the experience outcome and the number of probability associated with the outcome. Okay, and of course, like when we talk about the probability distribution, we have some condition and requirement. First of all, the function fx equal to actually, they will be the probability. Okay, so the first requirement will be what? The probability must be, each of the probability must be larger than equal than 0, okay, right? They cannot get a -1, right? They cannot get a negative values. They must be a kind of positive values, all right? But however, all of the probabilities have to sum to be 100%. That totally makes sense, and we learned it already. Okay? And yeah, we can go through this one and we talk about this, what we really want to do. So the same with this one. I will talk about this one a little bit very fast. So the same with this one. We collect for the table representation about how we generate it. For example, the unit of soul for the number of TV for each day, okay? So it's from 4 into 1, and we collect the data like this one. So the same units of cell, right? And then the number of day in a year. So that's meant in a year. No, it's not like in a year, in number of days, okay? And the x value and the fx value, okay? Fx does mean probability. So 4 of them will be the what we're going to really care about, okay? And the unit of cell that should be from 0, 1, 2, 3, and 4. And the number of days. For example, if they collect the data and they say over 200 days, so 80 days we can sell 0, nothing. 50 days we sell about 1. 40 days we sell 2 TVs. 10 days we sell 3 TV, and 20 days in 200 days we sell 4 TV. And that means the x value associated with this result could be from 0 into 4, of course. Okay. But however, for fx, how can we do it? The function very easy with the same thing, right? We take the number of the day and divide for 200 in total. So that's be 40%. And you also get all the number. Okay, and of course for this will be 100%. You see the possibility that's get in like 0 TV sell per day will be 40%. The possibility that we can sell like 1 TV like will be 25%. You see like that. So you can say like, oh, we're very high good probability that we can sell nothing a day, up to 40%, man. Okay. And at the same way, if you really want to generate for the graph like that, you can do it. Of course, you can do it. Okay. Go and generate it for recommend maybe just this graph. Okay. From 0 into 4. And we can see like how many percent of them. You see like most of the time the function have the possibility hide it for 0 TV cell per day. Okay, you got clear about this part? Any problem? Okay, I hope that you got clear, because this is very simple, so I don't think like any problem here. Okay, another thing. So we will try to talk about the different kinds of the distribution like that. We will apply for 2 main things. If the data have the finite result like this or have an infinite result like this, we have 2 different kinds of distribution we talk about. The first of all, there are 2 types of them, including the binomial, the portion, and also for the kind of uniform variable. We will talk about them in detail, and we first of all talk about the discrete uniform probability distribution. This will be the simplest example of the discrete probability distribution. So over here we talk about the first of all the uniform probability distribution. Okay. Now, what will be the uniform probability distribution? That's the same with what we have a talk about wrong for the die. Okay. And I just copy for the data over here. So for when you roll for the die, all the data, they have the same. We have about 6 different outcomes, right? And they have the equal. This over here, they have with the outcome we have equally likely. That means they have an equal probability, right? But this one they have the same probability for each outcome. So that's the reason why they say the uniform means đồng nhất. Tức là những cái giá trị mà xác suất mà xảy ra khi mà tất cả các outcome có cùng một cái khả năng xảy ra. Trong khi đó trên những cái này, các bạn có thấy rằng là các outcome nó có những cái giá trị khả năng các xác suất xảy ra khác nhau. Thì discrete uniform probability là dạng đơn giản nhất mình hay gặp nhất ở trong những cái ví dụ về roll the die đó, hoặc là toss the coin đó, là những cái ví dụ. So the possibility, the probability will be 1 equal or 100% divide for 1, right? For n. That's very simple. Okay. The expected value would be the sum of the x time for fx, and this will be what people say. And the variable, the variant, and the standard deviation, we can do it for this way. For this section, we just have to go up here and you're gonna do it and take a look into what will be the expected values. But we can do the same. I will one more time just generate for the graph for you and demonstrate for you to learn about expected value. Expected value means giá trị. Expected values, okay. So this will be the value, you can say like the mean value with the probabilities. I will not talk about this one and I delete it. Why can I delete it? Okay, yeah. So in case like 0, 1, 2, 3, 4, I already generate for all the things like this, okay. And this will be the possibility of the outcome, okay, of its outcome. And now the people want me to see what will be the expected value or the mean of a random variable measure for the central location. So that means what will be the average? What will be the average number of TVs so each day? Okay, if they have a question like that, I will have to find out what the people call expected value. And how we gonna generate for that? We first of all have to calculate for the multiplication between the values, the outcome of values, and the probability associated with that. And we measure for it. Very easy. Do it the same thing. Okay, time for 0.25. This would be 0.25. 2 time for 0.2. This would be 0.4. And all the thing you do will be just sum of them, okay, and then you sum up all of the value. Okay, this will be 1, 2. So you can say like in average, the store sell 1.2 TV per day. Okay, you got it? Okay. And another way for you, you just can use the product, the sum product function. If you don't want to generate everything like this, if you don't want to spend time everything like this, you can do at the same time use the product function. So you can use the sum product. Okay, it will help you to calculate for the sum of all the multiplication of two arrays. For my first array from 0 into 4. The second array from like this one, okay, and that should be all. And I click on, that should be 1.22. So I say the time I don't have to measure for this kind of like intermediate step, state for to measure for this one. Just save a lot of time. And the same thing you can do it with the variance and standard deviation. Remember, variance calculate not very easy, but standard deviation is just the square root of the variance. Okay. This will be how the people measure for the variance. They take this x minus for mu. Mu here, that could be the mean value. So mean value here will be 1.2. So 1 minus for 1.2, that should be minus 1.2. And that's the reason why, okay? And then they generate it for all the things like that, and just take really so long. The only thing I want to say could be like, because that's we know about the variance. Because that's we know about the variant, okay, the variant of the thing. Why it look like this? Okay, so I want to stand for the standard deviation. How I gonna generate it? Very simple. The standard deviation will equal to square root of the variant, right? The variant will be 1.66. Okay. That's what happened. Okay, sorry. Alright, so that should be 1.2088, okay, to 88.4, something like that. They will be the same. So that will be the result. Okay, I hope that you guys clear about this part because they very kind of very easy to understand. And I'm talking about the main topic of today. That will be the binomial probability distribution. And a binomial probability distribution, we have the two main functions to talk about that in a section. And in this part, I would just not talk about the theory itself, but also I would try to generate for the calculation on Excel for you to understand. So for probability of the binomial experience, including first, the experience consists of the sequence of n identical trial. Second, the outcome could be success of values. Okay, so I say about my identical trial would be like about the my shooting. Okay, my shooting like in let me give you an example. Let's think. Okay. Now let's just do it with the example. Okay, so for the number, for the shooting, like for the arrow competition, okay. So in arrow competition, the arrow competition, what does it mean? Oh, now this one, arrow shooting. Okay, you know about this one all? Okay, you must be know about all about the arrow shooting, right? And the charges of everything will be like you go and you for kind of like a ball and also the arrow to shoot into a target like this. And they kind of like, for example, the number of trial. Okay, number of trial mean the total time that you can shoot your arrow. Đó là tổng cộng của số lần mà các bạn có thể bắn cung. For example, 10 times. Okay. So for each one in a competition, they have a 10 turn of shooting for the arrow. And the outcome would be very easy. Outcome for each time that will be success and failure. Okay. So think about like when you shoot something, you go and do for the shooting. So you can have the success or you can failures in that one. Trong lần bắn thì mình có thể bắn trúng hồng tâm hoặc là bắn trật hồng tâm, đúng không? Khả năng là xác suất như vậy. Okay, and the probability of success denoted for P does not change for the trial of trial. Nghĩa là khả năng mà mình bắn trúng, khả năng mà thành công của mình nó luôn luôn là một con số cố định. Ví dụ, the probabilities of success time, okay, for each time I shoot will be 30%. Will be 30%. All right. So that will be denoted for P, something like that. Kind of like P. Okay, the not change refer for the station. So what this time when I shoot it, I have a 30% of successful, and next time I also will have a 30% of successful. The same thing happened like that, and I try it for 10 times. So the outcome for number of the time, right? The first time, second time, 3 times until like 10 times. I try it, okay, and the outcome would be what? The outcome for success for like one time, for the first one, for the first time I shot, would be maybe success. Okay, next time I maybe fail, next time I may be success, next time I may be fail, next time I may be fail, next time maybe success, next time maybe fail, success, fail, success. So this will be the example of the binomial probability distribution. When you see all of them, we have the limited number of trials. Okay, and the outcome will be have the 2 outcomes, success or failures, and the probability for success for each time will be 30%. It's not like 50-50, because if it's 50-50, that will be equal to the uniform, discrete uniform distribution. But however, this is a little bit different. We have the like it's not 50% of success, but like lower than or higher than. Okay. And this will be how the people do it. The interest will be the number of success occur in the end trial. For example, if the people have the question like, what will be the probability of that I will be successful for like 4 times, okay? So in 10 times, that I shoot my error. I want to see like what will be the probability that I can be successful for 4 times, okay? So the outcome, one more time I want to ask you. So the outcome about the number of success time will be what? Có mấy khả năng về chuyện là có khả năng bao nhiêu lần bắn trúng? Mấy đứa? Anyone? Student?
Maybe just one.
But how many possible outcome? If I try 10 times and each time I can success and each time I can fail, but what would be the outcome it could be? How many times? And the question would be how many times number of the successful time? Oh,
10.
it could be up
7.
to 10, okay? It could be up to 10, but can it could be 0?
Yes. Yes.
Yeah, maybe they all the 10 times I all fail. I'm a very kind of bad guy, unlucky guy. Even I have a, like 30% of success for each time, but I fail it all. So maybe I cannot make it like even like 1 time, but maybe 1 time, maybe 2 times, and maybe 4 times, 5 times, 6 times, 8 times, and up to 10 times, for example, like that. Okay, so this is the outcome for the number of success in time. Okay, like from 0 into 10, whatever, because I try for 10 times. Maximum I can win 10 times. Okay, so what will be the probabilities? The question will be probabilities of like success for 4 times. How can we do it? We can use the same function like this. They are detailed described in this function. That will be the combination of win like for over 10 times. We win about 4 times, right? And then we put in the number. This will be the probability of success. This will be 1 minus p will be probability of values, right? And all the things like that you can put into the function. But you don't have to do it, man. We provide a function called the binom. This, okay, the binom. This will be the function we use to calculate for all the possibilities. For example, what will be the probability that I successful for 4 times? Okay, and I use this function. So how we do it? We use binom dot this, okay, and then number of trial, number of S mean number of success. So this time I want to be success for 4 times at least. Okay, I put in trial. Trial mean the number of trials. So I try for 10 times. Okay. Oh, remember that I want to put this one into like F4 so I can save it because it should be fixed. Probability of success, that should be 30% for each time. Cumulative or not, over here you will put it like just 4. I will show you what will be different when I put it like true later. But this could be the outcome. Okay, this will be the outcome. So what does this mean? I will put it like in percentage so you can see. Sound fine. So that's mean, what does that mean this here? A 20.01% that this guy can be successful exactly 4 times. over 10 times of trial. Okay, you got it? And the same thing that we can generate for the probability that's for 0 time. What happened here? Oh, sorry. Okay, one more time. 0 time until like 10 time. And if I go and generate for that, okay, I go and generate for that for the total outcome. Let's insert for a graph. This could be the probability distribution. You can see over here the highest possibility that fall into 3 times. Okay, that's make up to like 26.68% that we can be successful 3 times. But if you talk about like successful more than 8 times, 9 times, 10 times, it's almost 0. That means very low possibility that you can be successful up to 10 times. Okay, right. Right, this could be the point. And I show you another guy, like we can do it for the cumulative probability. So when I talking about the probability of cumulative, that means I want to ask about the question will be, what will be the probability that I will be successful up to like 4 times? Okay, up to like 4 times. What does it mean? Does mean I can success like 4 times, but maybe I would just success like 3 times, 2 times, 1 time, and 4, and 0 time. So the cumulative probability, they will be actually just the sum of all the ones smaller than that. Okay. Okay, and that will be this one. I can generate it by like just calculate it by myself. Okay, but however, in the same time, I can do it like with the another function I will call the same like binom distribution, and the number of success will be 4, the number of try will be 10, and the probability of success will be 30%. I want to keep them fixed. Okay, all of them to be fixed. And the cumulative here, I would say true. Okay, and that helps me to answer that. If you just want to be success up to 4 times, maybe you success for like 0 time, 1 time, 2 time, 3 time, 4 time. You have up to like 84.97%. Okay, and you can score it and do it with the same. Of course, like when you go up into like very high level, most of the time this will be very close into 100%. Okay, like if you ask the question, what good probability does this success up to 10 times? Of course, 100%. I can be 0 times success, 1 time of success, up to 10 times, of course, 100%. Okay, so if you do it like manually in this way, okay, if you do it manually in this way for this example about the event electronic that's concerned about the low retention rate. Retention rate means the rate that the people stay in the company after a year. So when you are recruited into a company, so some of you will say like, oh, I hate this company and I want to quit it. So after a year, they say like, they look like 10% of the employees have leave. The turnover rate was 10%. Doesn't mean 10% of them no longer want to work for us. So thus, any hour employee chosen in random, manager estimate a probability that's 0.1%, 10%. That will be the person will not be with the company in next year. So that means the same thing happen, right? We can do it one more time with the same thing happen. So the successful time will be like 0.1. Okay, that means this not successful, but over here that means the probability that the people will quit will be 0.1. choosing 3-hour employee at random. What will be the probability that one of them will leave? Okay. Probability one will leave. So the outcome and the probability over here, we can do the same. And of course, when we choose 3, maybe no of them will quit, one of them will quit, or 2 of them will quit, maybe 3 of them will quit, all of them. But this will be all the outcome possible. Okay, and the probability they ask about will be exactly one guy will leave. We'll use the same function binom dot this. Okay, and the number of success will be 1 time only. Trial will be 3 times. Okay, the probabilities of success will be 10%, and that's cumulative. No, that should be fallen in cumulative. Okay, and exactly 24.3. You can see how the people do it in the binomial manual calculation. So before that, they do it like they just think about in first case, maybe the first guy will success. That means this guy will quit, and the 2 others will stay. Okay, so the probability of first guy will quit will be 10%. The 2 others stay will be like 90%. 90%, right? Time for the other, that should be this much, like 0.081%. That will be happen. And they think about like that should not stop like that. Maybe the first guy they will quit, but the 2 others stay. But maybe the first guy stay, but the second guy quit, and the third guy stay. The first and the second guy stay, but the third guys will quit. So by calculate all of the situation like this, they measure it by manually in this way, and they get like 0.243 for the probability. Another way, they use the function they provided, and you put it in, and they also generate for the same result. And the last way I already create and demonstrate for you guys, use the binom distribution. That's help you a lot in saving for the time of calculation. Okay, you do it just one time, and sorry, you just have to do it like one time, and everything will be available there, and you'll be fine. Okay. Right. You guys got it clear here, man? Chỗ này có gì khó khăn không mấy đứa? Nhưng thầy nghĩ chứ không khó gì đâu, cái này vẫn coi là học lý thuyết thôi. Tính toán nhiều nhưng mà thầy đã cố gắng làm tất cả cái này trên những cái hàm trên Excel rồi, thì sẽ dễ dãi hơn rất là nhiều. Và mọi người sẽ thấy rằng là nếu mấy đứa trong những chương này mà làm bằng máy tính tay á thì cực lắm. Nhưng nếu như những chương này mà làm bằng Excel thì rất là nhanh. Bạn làm có một xíu chứ mấy video mà thầy làm đây cho nó dài đó. Chứ còn video mà hướng dẫn của bay ở trên phần Canvas á, thì nó đâu có, nó khoảng tầm 10 phút 12 phút thôi là các bạn có thể nắm thuần thục được tất cả các kỹ năng này rồi. Okay, the same thing. Now that should be the binomial with the cumulative. The people, even when they have a generate for the table of calculation, that's stupid. That's very long ago, and the people do it with the binomial probability distribution by this way, but nobody uses anymore. We just need the Excel to do it all. Okay, that should be all the thing about the binomial probabilities distribution. So the expected value, you have to take a look why. Variance, you take a look how to measure for that, and standard deviation, how to measure for that. Basically, I told you standard deviation will be just the square root of variance. So you have the variance, take the square root, you have the standard deviation. Okay, so you take a look into how they calculate it. Oh, okay, it's not my fault. I will not do it. I say the time. Okay, now let's talk about the Parsons probability distribution. So this one will be so for the question line, we may assume that they have an infinite sequence of values. The same thing which I told you already about the number of the customer coming to the store a day. Okay, so there will no upper limit. maybe have just 0 customer come to the store, but maybe have a 22, maybe 100, maybe 1,000, maybe 10,000. So we don't have the upper limit compared to what we already generate with the binomial probability distribution. This one we have a 10 trial, so that's the reason why the upper will have the limit. Okay, and now let's talk about this one very quick. Okay, Poisson probability distribution. Ah man, that's shy. Okay. With the Poisson probability distribution, the people can talk about the example. The first example, they say, I already tell you about the number of customers come to the store a day, right? Another one may be number of vehicle arrive in the toolbox in 1 hour. The toolbox will be, oh, you maybe don't know about this one. The toll, okay? The toolbox will be where you drive through, and this will be what the people normally call in Vietnam trạm BOT. Okay, so you drive through, and you have to pay the money to spare to you for the road, right, for the traffic on the road. So that's just a way for you to return back for all the investment for the manufacturing and the infrastructure that people invest in the road. Okay, so the number of the toolbox, that means the number of the car go through the toolbox will be count for a day. Maybe in 1 hour, just 1 or 2 the car can go through, because that's very like pandemic day. The people don't want to go out, or maybe they should be kind of like the stormy day, right? Which had the hurricane. So nobody want to go out because it's unsafe. So there are no car or just 1 or 2 cars get through. But however, who knows, right? Because for the tool part, maybe it's a very busy day like this, and there are thousands of the cars waiting to go ahead. And if you exactly waiting and count for the number of the car, it may be up to 1,000, maybe up to like 10,000. So in this case, that will be the number of the vehicle arrive in the toolbox will be in 1 hour will be unlimited with the upper, but then the number will be still be countable. Okay. Another question will be about the example number of the connectors in 14 in feet of the pipe boards. So connectors, okay, sorry, connectors on the pipe board. Pipe board means this is the pipe board. Oh no, nobody know about pipe board. Okay. For example, this is the pipe board, cái tấm gỗ thông. Okay. So in the pipe board, we have sometimes this will be the connector, những cái mắt gỗ. So for example, in this much, in the kind of like 1 meters of the pipe boards, we have maybe up to like 30, 20, 40, maybe 100, maybe 40s, maybe 120 of the connectors. But sometimes they're quite clean like this. Just have a 1, 2, 3, 4, 5 the connectors. Sometimes just 1 like this, and sometimes they totally clean and they don't have any kind of like connectors on that one. It's up to the probabilities. So in this way, the number, the Poisson distribution random variable, they will go to generate for the probability that we want to know the number of the occurrence in a like interval of time or space. And in this one, we will go to just deal with the lambda. Lambda means the mean value that's of the occurrence. For example, I say the number of vehicle arriving in a toolbox in 1 hour will be 1. Like in average, just 1 car get through the toolbox. So that will be in look like this way. But if that's be getting bigger and bigger, like the lambda equals 4. 4 mean here, in average 1 hour, there will be 4 vehicles that's passed through. Okay, so it look like this one. It will be 10. It will look like this one. Okay. So that will be what I say. The probabilities of occurrence in the same for the 2 interval of equal length, and the occurrence of the non-occurrence will be the same. Okay. And this could be what the people normally talk about, the Poisson probability function. Very hard. Milk here, that means the same with the lambda. Okay, if you say the lambda will be 5, or sometimes the people call the milk, that means the mean number occurrence in the interval. That means and x will be what we really ask about. Okay, that could be the exponential number 2.71 if you have learned it in the grade number 12. And this will be the popcorn. That could be the equal to all the time, the multiplication of all the from x into the 1. Okay, so you can use this one, but at the same time you can just use it for 2, whatever. So in this case, the question of the example something like this. For example, the Mercy Hospital. Mercy Hospital had the patient arrive in the emergency room of the Mercy Hospital at the average rate of 6 per hour in a weekend evening. Okay, so this means that's the mean value, right? Mean value. This here, this will be lambda. Okay, lambda. Okay, so normally that will be 6 guys come into the emergency room, phòng cấp cứu. Thì có 6 người tới cấp cứu đúng không? Six people, 6 patients. Okay, over an hour. Okay, what will be the probability of 4 patients to arise in 30 minutes on that night? Okay, because that normally we know that in average 6 patients will be in an hour. So now what will be the probability that 4 patients will arrive in 30 minutes? So first of all, we have to just make a kind of transformation, right? Because the people say about probabilities of 4 patients in the interval of 30 minutes only. We have to measure it over here. So actually it's equal to how many patients in 30 minutes? How many patients in 30 minutes?
3.
3, yeah. This should be 3 patients in 30 minutes. Okay, it looks like normally 3 persons in 30 minutes. And now you ask for like probability of 4 persons come in 30 minutes. It's a little bit more than usual, a little bit. And what will be the probability like that? You can use the same function over here for F4. You put into this one, right? You can generate if you want. But I will use another function. I will what people call the Poisson distribution. Poisson does be a kind of like a French mathematics, so we don't know exactly how to just spell his name, but like this way. Okay, and we can generate for the probability like that. So the probabilities we will use it very quick by use the Poisson. Okay, dot distribution, and then we open the parentheses. X does mean we want to have 4 patients. Okay, mean value, that's normally how many patients in 30 minutes? 3, right? The cumulative, now we will just put in form. Okay, and you will see over here, that means we have a 16.8% that have a 4 patient come to 30 minutes. You can do it the same. Okay, you can test it with the probabilities and the outcome number. So like 0 guy come, 1 guy come, 2 guy come, 3 guy come, 4 guy come, 5 guy come, 6 guy come, maybe like up to 10 guy who see. But normally most of the time this will be 3, right? So you can check it. They're the same function. You use the Poisson of this distribution. X will be 0. Mean values, that's mean 3. Okay, all the time this will be 3. Form, not cumulative. I just want to see, and I put into like percentage and gonna expand it. You see This is what people normally have. Okay, the probability is up like 0 time, just 5%, 1 time 14%, 15%, something like that, 4 times 16.8%, 5 times. But however, when you raise this up for the larger number of the people, like up to 20 guys come into a day, that's 9. I guess it's pretty like 0%, like about 13. There's 0%, almost like 0%. That's 13 guy will come, because that normally we just have a 3 guy come, right? Đây, cái này là ví dụ về trong trường hợp mà bình thường thì chỉ có 3 người tới cái bệnh viện của mình thôi. Bây giờ ví dụ 4 người tới thì cái khả năng nó thấp hơn xíu, vì bình thường là khoảng 3 người. Ví dụ 0 người hoặc là 1 người nó không khác. Nhưng mà những cái giá trị càng xa này, mặc dù là mình biết rằng là có khả năng là cũng có 10 người tới, nhưng mà khả năng 10 người cùng xuất hiện một lúc rất là thấp, chỉ có mức là 0.08% thôi. Cả những cái mức giá trị cao hơn nữa, ví dụ tới 20 người hoặc là 17, 18 người là gần như 0% luôn giá trị. Yeah, thì vì mình biết là bình thường nó có tầm 3 người. So this is the way for us to measure about, understand about the thing like, okay, this very low probability that if I generate it, okay. So you can see like we have very low probability that we will have a lot of patient, more than like 7 or 8% patient. So we just most of the time the probability will be most of all like from 0 into like 7 guy, and based on this we can allocate for our people, for about our like doctors to just take care of for the patient. Rồi, như vậy toàn bộ cái nội dung tới đây là nội dung của phần mà Poisson probabilities and the other thing. Okay, you can take a look into how to measure everything else. This could be the end of this chapter. So we have the Poisson probabilities, and we also have a learn about the binomial probability distribution. So if you want to take a look on that, this should be all here. So basically, this could be all about math, and we can easily solve it. We can easily solve all the kind of question like this based on the function on Excel, and that's very simple. So that's what I say is very easy. All right, guy. Any question about the section today? Any question? Okay, fine. So that's look very simple, right? The today section, they will not have too many work to do. You guys just come home and maybe later in these chapters I will try to post for the today section for the full video for you to just follow, so you can take a look on that. Okay.